going to bring it down to earth for all of us. And I'm going to talk about the life cycle of AI, those AI models that really are going to make all these smart cities and moon landing and Mars landing possible. So let's talk about that. I'll talk about AI and analytics life cycle and its 3 qualifications and also the value of AI and analytics life cycle. And I have my colleague here, Joseph Henry, who is going to talk about Workbench. And going back to what Fatima said about allyship, for us, Workbench is kind of like an allyship between SAS and open source programmers, where you can bring in your skill set, your preferences to code and to use AI and analytics. Okay, let's get into that. The intensity of today's environment demands organization to be outcome-driven, and AI is critical to scaling human productivity and to achieve the high outcomes in any organization. And AI follows a very repeatable life cycle. This is what we call AI and analytics life cycle, going from questions to decisions. Let's talk about what an AI and analytics life cycle is actually. When asking a question, the first thing that we start with is getting access to data in an organization. We have to analyze that data and build an inventory, and then we capture this data in our data catalog. We capture the metadata and profile the quality of the data. And then after that, we get into data management, essentially, which is joining the data from different data sets, adding new calculations, and building derived columns. So the goal is really, for example, to make a prediction or classification. Let's say we want to make a prediction on where the spaceship is going to land on the moon or Mars. So these are, if you look at this image, this teal column would be the indicator of the column that we want to predict. We want to take this data and we want to build a model tournament throughout the whole organizations. We're going to build numerous amounts of AI models. And from this, we want to determine the champion model, the model that is going to give us the best outcome and help us to predict our target variable. And so once we pick that champion model, then the next step is model management, which allows us to put this model with all the other AI models and take it into decisioning. What we really care about in an AI and analytics life cycle is going from questions to decisions. Eventually, we want to make a decision. We want to make a decision about our predictions, our organization's goals, and all of that. So once we deploy this model into a business process, in this case, for example, might be an online loan application. We want to make sure that we can approve somebody for a loan, for example. We have to monitor the performance of these models. So we put these models into production. They're running, they're doing forecasting and predictions for us. But we want to monitor the performance of these models. And because the data shifts, the models might decay. So we go back to reiterating, going back to the whole concept of AI and analytics lifecycle from the beginning, from reviewing the data, doing data management, developing models, building the models, evaluating the models, putting into deployment and production and monitoring them. And that is what we call an AI and analytics lifecycle. Getting from questions, 1 billion points of data into one decision or numerous decisions. And so at SAS, you would think that, what is our market value? We are, first and foremost, a cloud-native AI and analytics company. And SAS VIYA is the foundation for this, a cloud-native, cloud-portable platform that gives you choices to control, to run AI and analytics wherever and however you need it, and supports all the components of this life cycle. Now, throughout this entire life cycle, there are 3 key qualifications that we need to focus on: performance, productivity, and trust. So when we're putting an AI model into production, these are the 3 key qualifications that we need to focus. Let's talk about each one. What is a measure of productivity in AI? It is not about moving data from on-premises to cloud and then running seamless amount of SQL queries. It's not about building homegrown data integration frameworks so where the expertise is lost whenever the employee leaves the company. And it's also certainly not about waiting 3 weeks for the data engineer to give you the new set of data sets so you can retrain your models. That is not productivity. In the world of AI, decisions made from models in production are the singular proof point of productivity. So it's all about decisions. It's all about intelligent decisioning and getting into decisions. And SAS VIYA automates this intelligent decisioning process, getting from data to decisions. It automates the AI analytics lifecycle from data management, preparing the data, developing the models, and deploying the models and getting into production. In addition to integrating with APIs, open data formats, and all programming data formats and programming languages. And finally, it's also about collaboration between the organization, collaborations between the business analysts, the data scientists, the developers, and the IT folks. So this is what brings productivity. What about performance? Let's talk about performance as it matters to AI and in the cloud. There are 3 cloud qualities that people talk about. It's about agility, resilience, and cost improvement. There's no question that cloud brings agility and resilience, but not so much about cost improvements. Cloud bills tend to be a bit more expensive, more than what we expected. So we actually started a program at SAS in R&D a few years ago to focus on improving our AI models so then they can run faster. And today, our AI models run 16 times faster than what they used to run in 2021. And we've also done some analysis, and independent research has done some analysis and found out that our platform is 30 times faster compared to open source. You can actually scan this QR code and get to that. So everything I already talked about is about performance and productivity. But what about trust? With a lot of power comes also risk. Any powerful technology has risk, and that brings me to trust. Trust in any AI software. It's important to understand that AI is rooted in mathematics that study the past to make decisions about present and about future. And so if our data was out of date or underrepresented, that perpetuates to the models that we're creating and to the decisions that we're making. So all these AI models needs to be transparent and needs to have a better explainable, and they needs to be fair. It's all about, going back to what Fatima said about having a representation of the whole community. And that also comes back to our AI models. We need to make sure that the data that the AI models are based on is an inclusive of the whole population. And so that really matters when it comes to trust in the AI models and making sure that decisions are transparent. So I talked about AI and analytics lifecycle, the process of going from data and questions to decisions. And every AI project is a team sport. We've got developers, data scientists, business analysts, and IT folks, and they're all seamlessly collaborating in the same environment to create code and create AI models. And although it's a team sport, each one of us have unique skill sets. Each one of us have programming preferences. And so that's why we came to develop SAS VIYA Workbench, which is essentially it's a lightweight, fast deployment environment that provides developers and data scientists their own preferred space to work, whether you want to work in SAS, in Python, or generally open source programs. And I'm going to ask my colleague, Joseph Henry, he's one of the masterminds behind SAS VIYA Workbench, to give you a short demo of that.
Thank you, Katie. Now, I'm going to do something that I wouldn't recommend any of you do, and that is demo beta software on corporate Wi-Fi here in front of 1,000 people. But let's give it a try. So can you go ahead and put this up on the screen? At some point, it'll be up there. No, it exited. There we go. Okay, so Katy said all that stuff about how SAS is trying to bring these new platforms to the industry, right? But all of this is powered by developers, right? Developers write analytic code, they write score code. All this stuff needs to come together, but at the end of the day, we need developers to be able to write SAS, Python, R, whatever they're using to actually get data into these models, okay? So what I'm gonna do here is I'm just gonna sign in. If I can enter my password. Now, what's happening here is this is the SAS VIYA Workbench. It's just a single page web app, okay? You guys have seen this before. So I'm just gonna click Create New Workbench here. And for the sake of time, I'm just gonna choose all the defaults here. Okay, so pretty simple form, pretty simple setup. I didn't really have to do anything, no configuration, no install. It's just get an account, log in, and go. Now I'm gonna go ahead and click this Open in Visual Studio Code button. And this is being powered by OpenVS Code, so all open source. And an environment is being curated for me that has SAS and other open source statistical software provided. So I made this workbench a little bit earlier, or this workspace with some demos for this, this thing. And I'll go ahead and open up a SAS file and just click Run. Now, I'm gonna let this sink in for just a second. I went from a login page to creating a compute environment and running SAS code and viewing results in less than a minute. And anybody that has used SAS in the past, this might not have been your experience as fast as this is. And that's pretty cool. Just this right here, just having on-demand compute and an analytical environment would be a pretty good product. But there's a little bit more here. Let's exit out of this and go back to the main page here. So Katy mentioned scalability. We can scale this environment on demand. So I can go from, right now I'm using 2 cores, 8 gigs of RAM. So I use the default system. I'm just gonna scale up to 4 cores, 16, okay? So the account I'm logged in with has options for 2 compute environments. Let's just click restart. And now I'm literally going to double the power of what I was running in less than 5 seconds. Go back to where I was. I can pick up just where I started before, but now using much more compute, okay? Now that is pretty cool, all right? But SAS is a proprietary language, and not everyone knows SAS, right? It is a very good, very powerful analytical language, but a lot of people are learning Python now in schools, and they really want to program in Python. Well, this environment provides Python as well, along with most of the big analytical packages like scikit-learn, numpy, scipy. So I can just open this Jupyter notebook that has some Python code in it. Let's go ahead and run this. Okay, and so this is running in that same environment I was running SAS in, but there's something a little bit different about this. So this isn't just using scikit-learn as it is. SAS has made language bindings that actually load the analytics that we run in SAS now in Python. I'll give you a little bit of example of what I mean there, okay? So let's open up this SAS file right here. This is just running a logistic regression on a little data set, right? So I'm just gonna import the CSV, put it into a SAS data set, and run a logistic regression on it, all right? So when this is done, we'll see the results over here, and let's focus on the parameter estimates, right? So these right here are the weights of the model that are being trained with respect to the input data. You don't really need to know what that means. It's just numbers are important, so let's focus on them. All right, so now let's open up a Python notebook, all right? So we're gonna run this, and one of the things you'll see, if I go down to the parameter estimates again, is that they are the same numbers, okay? Now I'm gonna open up an R file, right? This is also a logistic regression. Go ahead and play this. And when this is finished, we're gonna look at the parameter estimates again with this one right here. Same numbers. So now I've ran kind of the same data set with the same regression in SAS, Python, and R, same results, all right? What this means is that SAS is an analytics company, and we provide trusted analytics, and we've done it for generations. I mean, people have been running the same SAS code for 30 years with no change, all right? What you get from SAS is trust in the numbers, trust in the software, and trust that we're gonna support it for a number of years. Now, this product is built with open source, for open source, on open source, right? But it's also providing SAS as well, right? And so this is nice if you like, you know, programming in VS Code, which I do, but we're also flexible as well. So I can open this same workspace up in Jupyter Lab instead of VS Code. If you're just a Python guy or girl or whoever, you just want to, you know, run statistics in notebooks, we can do that. So with one click, I've restarted this, and now I'm in Jupyter Lab. I can go into, let's just open one of these notebooks that I did before. Double click. Now I'm doing the same thing in Jupyter Lab that I was doing before in VS Code. Super simple, super easy. And one of the cool things about this is that if I walked away, you know, after a little while, it's gonna notice that I'm not using it anymore. It's all gonna scale down. And so your cloud costs scale down when you're not using it. So I could just let this stop in itself, or I could press stop, and now everything's gonna be scaled to 0, and so you're only being charged for what you're using, right? So, in conclusion, I'm really terrible at ending these things, but that's pretty much the rest of the demo. But I do want you guys to know that this is the future of how SAS is going to bring analytics to developers on the cloud with open source for open source. Thank you, and